It's a pleasure to have the presentation on STCrowd, a multimodal dataset for pedestrian perception in crowded scenes. This is my presentation overview. I will first introduce the background. Pedestrian perception is intractable for these three reasons. First, pedestrians are not rigid body and they can have various poses. Second, humans are relatively small for sensor to capture compared with other agents. For instance, in LiDAR point clouds, pedestrians in the distance are usually represented as a free, sparse point. Third, people tend to close with each other when working, which makes the detection of each individual person harder. Occlusion in the crowded scenario is also a problem for pedestrian perception. Following these motivations, we proposed a large-scale multimodal pedestrian-oriented dataset in crowded scenario with 3D menu annotations. Our dataset can be used for various tasks, including LiDAR-only, image-only, and sensor fusion-based pedestrian detection and tracking. We propose a novel method to enhance LiDAR-based pedestrian perception in crowded scenes and achieve SOTA. STCrowd provides 2D and 3D image annotation, 3D point cloud annotations, and joint annotations for consecutive frames and can be used for detection, tracking, and prediction. This is our statistics details and our sensor setup. For more details, it can be read in our paper. Our dataset has three properties. First, divergence and weather, as shown in these figures. The first row are some clear weather, and the second row are cloudy and rainy conditions. Second, high density, and this is the most important things of our dataset. We divide the density level into these 4 levels, with corresponding number pedestrian in the frame. We compare with other relative datasets in this table. Our dataset has 20 pedestrians on average, which is obviously more than others. The last two values shows the density of the distribution of pedestrians. The last value is the average number of pedestrians in 2, 5, and 10 meters centered on each pedestrian. Since when people gather, point clouds of different instances always sit with each other. We also have diverse human pose. We propose the density-aware hierarchical heat map aggregation and make the model learn the attention on the location of individual and propose multi-scale predictions covering regions with different density. We model the global attention with transformer and apply the triplet query key value attention layer to extract the correlation among different locations and reweight them. We design the spatial hierarchical Gaussian score heatmap supervision to tackle the problem of various density distribution and background influence. The cross-level heatmap is downsample from the regular one, in which the positive region occupied a larger portion targeting a balanced foreground and background ratio. For the fine-grained level heatmap, it can clearly distinguish the closer pedestrian for accurate one-to-one alignment. We compare the results of our proposed method with existing enter-based and enter-free methods. The proposed method achieved the SOTA. We further provide the visualization results for the detection task in crowded scenes. Our method performed much better, even covering this challenge pedestrians when they are extremely close to each other and occluded seriously. In addition, our method makes fewer false prediction on the background than the backbone model. We perform application experiment on various backbone and get different improvement. These are the baseline results on tracking and the prediction tasks. This is our dataset homepage. Following challenge will be open and welcome to participate.